All right, so let's have a look at this question here. It says, if y is equal to tan x, find dy over dx. So the question is, how do we differentiate tan x? First of all, tan x can be rewritten in a different format. So tan x can be rewritten as sin x over cos x. Okay, so if you have sin x over cos x, we know the differential of sin x and we know the differential of cos x. And if you don't remember that very well, so you can always remember to this method here to always remember it. So write sin x at the top, cos x at the bottom, arrows going clockwise with a negative sign on the left hand side. So if we are differentiating, we're going clockwise. If we are integrating, we're going anti-clockwise. So if we're differentiating, we're going if you're differentiating, going clockwise. If you're integrating, you're going anti-clockwise. That's a good way for me to remember the differential of sin x and cos x. So now that we have established we can use the quotient rule to solve this, what is the formula for the quotient rule? So again, you do not need to memorize this because it's given to you in the formula booklet, but it goes as the following. So dy over dx, okay, can be solved by doing v times du over dx minus u times dv over dx all over v squared. And this is for when y is equal to u over v. Okay, so in this case here we have, let's have a look on how we can do this then. So my u is equal to sin x, and my v is equal to the denominator, which is cos x. So in this case here, my differentiation of sin x with differentiation of u will be du, which is equal to cos x. And differentiation of v, which is cos x, dv is equal to minus sin x. Again, this is using the this method that I use here on the top right corner. So now that we differentiated them, let's try to substitute them back into the formula. So my dy over dx simply becomes my v times du, so that would be cos x multiplied by cos x, minus, because it's a negative sign, my u, which is sin x, multiplied by my dv, which is minus sin x. And this is all over my v squared. My v squared is simply cos x all squared. So if I simplify here, cos x times cos x gives me cos x squared, minus sin x times minus sin x gives me minus sin squared x. And this is still all over cos squared x. So what's happening? We have a minus and a minus, which makes a plus. So cos squared x plus sin squared x is all over cos squared x. So now the question is, what's sin squared plus cos squared? Wow, I remember that using the trig fast identities, that sin squared x plus cos squared x can be written as 1. So if I use this trig identity, I can rewrite this as following, as 1 over cos squared x. And we know that 1 over cos squared x is simply same thing as rewriting as sec squared x. Well, now we have shown that if y is equal to tan x, then dy over dx is equal to sec squared x. There we go. That's how you find the differentiation of tan x using this longer method. It's easy to remember it, but just in case you forget in the exam, or even they tell you to use a quotient to show this, this is the way that you do it. Hopefully this is all clear now.